Class 9 Chemistry, Chapter 7, Study of Gas Laws. Dear students, in this chapter, we will take two laws, namely Boyle's Law and Charles' Law, and thereafter, after combining both the laws, that is Boyle's Law and Charles' Law, we will be having another law called the Gas Law. In this chapter, we will see the respective changes in the pressure of the gas, volume of the gas, and temperature of the gas. So students, before we take up the laws for discussion, let us see the behavior and characteristic properties of gases. So first property is composition of gases. Let us see, gases are made up of tiny particles or molecules moving in all possible direction at all possible speeds. The molecules are negligibly small in size as compared to the volume occupied by the gas. So students, we consider the volume of the real particles to be very negligible as compared to the volume of the whole space. For example, students, suppose it to be a container and it is having certain molecules of gas. So in this volume, for example, let it to be the 2-liter volume container. So if I compare the number of particles and volume of particles, of course these are particles, so they must be having certain volume, these particles, okay, these are gaseous molecules. So if I consider this whole 2-liter, that is volume of the container, to the volume of these particles, so what I will observe, that the volume of these particles is very negligible or very less as compared to the volume of the container, means the volume occupied by the gas. Then students, we have gases have neither a fixed volume nor a fixed shape. Right from the beginning, that is from class 6, 7, 8, all of you know this property of the gases, that they do not have a fixed volume or fixed shape, means they can have any shape, means the container shape will be their shape only. And also the gas, that is volume of the gas, it is not fixed. How come? For example, if same amount of gas you are taking in a 1-liter container, the volume of the gas will be said to be 1 liter. If the same amount of gas you are taking it in 2 liters, the volume of the gas will be called as 2 liters only. It means gases, they will occupy the every possible space which they are having. So if it is the container's volume is 1 liter, gases will be having 1 liter volume. Same amount of gas, if it is passed into another chamber, another container having 3 liters volume, again gas will be called to have the 3 liter volume only. Then gases exert pressure in all direction. You know, if there is a solid in a container, so most of the pressure will be exerted at the base of the container, less pressure will be exerted at the walls of the container. If there is water, again at the base most of the pressure will be there, and at the walls of the container somewhat less pressure will be there. But if you consider the gas molecules in a container, so they will strike with the equal speed, you can say, to the lid of the container, to the walls of the container, to the base of the container. So it means gases exert pressure in all direction. Then you know, gases are highly compressible. There are large interparticle intermolecular spaces between gas molecules, and this accounts for the high compressibility of gases. On applying pressure, the molecules come closer, thus decreasing the volume of the gas. So we can say, if you want to compress solid, if you want to compress liquid, and if you want to compress gas, then you will see that gases are highly compressible. How come? Because they are having the interparticle space available between them. So if gases are highly compressible, it means they are highly expansible also. And now you know the reason for the same. Then students, gases have low density, that you already know. Solids are having the highest density, then liquid in between that of gas and solid, and then gases have the low density because they occupy a large volume to have a little mass. Then students, gases have a natural tendency to mix with one another, and this phenomenon is called diffusion. Okay, interparticle intermolecular spaces in a gas are very large. When two gases are brought in contact with each other, their molecules mix with each other in such a manner that a homogeneous gas mixture is formed. You know, for example, if you are having a deodorant, body deodorant, in one room you are spraying over your body, in another room the molecules will pass easily. It means the molecules, the gaseous molecules, they show the diffusion. So what is this diffusion? Here once again let us see. Diffusion is the process of gradual mixing of two substances kept in contact by molecular motion. Then another property of the gas is that they can be liquefied. It means if you are applying a high pressure over the gas, or if you are just taking the temperature down to the cooler side, the gases can get changed into the liquid phase. Now students, if we increase the temperature of a gas, its kinetic energy increases. So it is written, the average kinetic energy of a particle or molecule is directly proportional to its absolute temperature. Okay, and what is this absolute temperature? It is the temperature in Kelvin scale. It is the temperature in Kelvin scale. You know, temperature is generally measured, we generally talk about temperature in degree Celsius, but this is the Kelvin scale, which is the SI unit of temperature. Okay, so you are well aware of the fact that when the solids, they are heated up, they get changed into the water molecule, and once again when the water molecules, they are heated up, here water means I wanted to say liquid. Solids can be converted into liquid by raising the temperature, and liquid can be converted to the vapor or gaseous phase by raising the temperature. So what do we see? That on raising the temperature, the kinetic energy of the particles, they get increased, and they show a more random motion. Okay, and hence meanwhile doing so, they will just get away from each other. Now let us see what is this absolute zero. Now students, I told you absolute temperature means Kelvin, temperature in Kelvin scale, but if it is written absolute zero, it means we are talking about the temperature at Kelvin scale to be 0 or 0 Kelvin. So the temperature at which the molecular motion completely ceases, theoretically concept it is, on the Kelvin scale is called the absolute zero. Students, you know, whenever we are just taking the temperature down to the cooler side, the randomness of the particles, it gets decreased, and if we take the temperature to 0 Kelvin, okay, if we are taking the temperature to the 0 Kelvin, the molecular motion will completely cease.